Good day everyone, my name is Jelyn R Agris and we're going to find the derivative of trigonometric function, inverse trigonometric function, natural logarithms, the exponential functions, the general exponential functions, and the derivatives involving log with the base. And now, f of x is equal to 3 cotangent x minus 2 cosine x. We're going to find the derivative of this trigonometric function. F prime of x is equal to 3. The derivative of cotangent x is negative cosecant squared x minus 2, and the derivative cosine x is negative sine x. So let's simplify this equation. F prime of x is equals to negative 3 because of this negative sign of cosecant squared, positive 2 because of the negative sign multiplied by negative, so the result is positive 2 sine x, and that is our final answer. So now let's proceed to the derivative of inverse trigonometric function. Y is equal to the arc secant of 2s plus 1. To find the derivative of this, we're going to use d over dx times this arc secant of u equals to u prime over the absolute value of u square root of u squared minus 1. Let's find the u and the u prime. Our u is simply 2s plus 1, and the derivative of this is 2. So y prime is equal to our u prime is 2 over the absolute value of u 2s plus 1 and square root of u 2s plus 1 squared minus 1. And this is our final answer. So now, let's proceed to the derivative of natural logarithms. Y is equal to ln of x cubed. Then to find the derivative of natural logarithms, we're going to use d over dx times ln u, or the natural log of u, equals u prime all over u. So let's find first the u prime and our u. Our u prime is the derivative of x cubed. By using our power rule, 3x squared. And our u is simply the x cubed. So y prime is equal to our u prime 3x squared over the u x cubed. We can simplify this through 3 times x because of the x squared, and x times x times x for the x cubed. So let's cancel out the 2x, and the remaining is 3 over x. And this is our final answer. So now we're going to find the derivative of exponential function number 18. Y is equals to e to the power of 2x over 3. To find this derivative, we're going to use d over dx e to the u equals e to the u times the u prime. So let's identify first the EU and the U prime. Our EU is simply this, e to the power of 2x over 3, and our U prime is the derivative of 2x over 3. And to find the derivative of this, we're going to use the quotient rule, which is f to the g prime minus g to the f prime over f squared. This is going to be our f, and this is going to be our g. So simply substitute f over 3 times the derivative of 2x is 2 minus the g 2x, and our derivative of 3 or f is 0 because 3 is a constant, over our f 3 squared. So 2 times 3 is 6 minus 2x times 0 is 0 over 3 squared is 9. So equals 6 over 9. Simplify 2 over 3, and that is our u prime for this. So 2 over 3. So y prime now is equals to our EU is e to the power of 2x over 3 times 2 over 3. And that is our final answer. In this video, we're going to find the derivative of general exponential function y is equals to 5 to the power of square root over s, or y is equals to 5 to the power of s to the 1/2. So to find the general exponential, we're going to use the formula d over dx au equals au times the u prime times ln a. So let's first identify the au, which is the 5 square root of s, and our u prime is the derivative of s to the power of 1/2, and ln, so our a is the base 5. So to find the u prime, we're going to use the chain rule, s to the power of 1/2. Chain rule, we're going to use the n the power times the s, and n minus 1 times the derivative of this s. So substitute, this is our s and this is our n. So our n is 1/2 times the s, our n there, or the power 1/2 minus 1 times the derivative of s is 1. So 1/2 s to the negative 1/2, because 1/2 minus 1 is negative 1/2, times the 1. So simply 1 over 2 square root of s, but so that the negative sign would be gone. And that is our u prime, 1 over 2 square root of s. So simply y is equals to our au, or the 5 square root of s, times our u prime, 1 over 2 square root of s, and our ln a, which is 5. So simplify y prime. Our y prime now is 5 square root of s times L of n, 5 over 2 square root of s. And this is our final answer. Lastly, we're going to find the derivative involving log with the base of a times the x. Y is equal to the log the base of 5 times e to the power of x. To find the derivative of this, we're going to use d over dx times the log a to the u equals to the u prime over u ln a. So first, let's find the u prime and our a. Our u is the e to the power of x. U prime is the derivative of e to the power of x. Then our a is the base 5. So to find the derivative of e to the x, we're going to use d over dx e to the u, or the exponential function, that equals to e to the u times the u prime. Our e to the u is the e to the power of x, and our u prime, the derivative of x, which is 1. So d over dx e to the x is equal to our eu is e to the power of x times 1, our derivative of e to the x, and our answer is e to the power of x. They are just the same with our u. So now y prime is equal to, substitute our u prime with e to the x, lower u, which is e to the x also, and our ln, our a, is the base 5. So simplify, we can cancel this and this. Y prime is equal to 1 all over ln 5. And that's it, our final answer. Thank you.